The polar vortex is a swirling mass of cold, low-pressure air high above the Earth's poles, a giant atmospheric whirlpool. In winter, it acts like a fence, keeping the coldest Arctic air locked over the North Pole. When strong, it keeps winters in North America and Europe relatively normal. But when the vortex weakens, that fence breaks down. The cold air escapes, plunging southward and bringing severe cold snaps and snowstorms. The vortex itself isn't a storm. It's a large-scale atmospheric feature whose strength shapes our winter weather. Meteorologists closely monitor its stability to predict if the cold will stay put or break free. A stable vortex means typical winter. A disrupted one means we brace for Arctic blasts. The polar vortex is always present, but it's most influential in winter, when the temperature contrast between the pole and equator is greatest. As winter deepens, the vortex strengthens, until something disrupts it. That's when a normal winter can turn unforgettable, all because of changes high above the polar cap. Understanding the polar vortex is key to predicting why some winters are so much harsher than others. The main trigger for a weakened polar vortex is a sudden stratospheric warming, or SSW, a rapid temperature spike in the stratosphere miles above Earth. In days, temperatures can soar by up to 50 degrees C, disrupting the vortex and setting off a chain reaction. This warming is caused by powerful planetary waves from the lower atmosphere, which slam into the vortex and slow it down. When strong enough, these waves break into the stratosphere, injecting energy and causing the vortex's winds to weaken or even reverse. The SSW of early 2025 was a textbook case. Forecast models spotted a huge energy pulse from the North Pacific, triggering a rapid temperature spike over the pole. The vortex lost its structure, wobbling and elongating, clear signs that Arctic air was about to escape. While we don't feel the stratospheric warming directly, its effects cascade down, changing the jet stream and steering weather systems. A weakened vortex means a wavier jet stream, letting frigid Arctic air plunge south. This is how SSW events unleash extreme winter weather far from the pole. Understanding this connection is crucial for long-range forecasts. The 2025 SSW set the stage for a winter of dramatic cold and snow. It all started with a sudden jolt high above the Arctic. What made the winter of 2025 remarkable was the timing of the SSW. It struck in late November, much earlier than usual. This rare, early disruption primed the entire season for a different, more aggressive pattern. Instead of a gradual onset, winter arrived with a sudden blast of Arctic air. Meteorologists quickly saw the vortex's winds slow and reverse, confirming a major breakdown. The Arctic air, once contained, was now free to surge south into North America. The early timing meant the effects would hit right as holiday travel and energy demand peaked. Communities had to prepare for a harsh start, not a gentle slide into winter. Scientists seized the chance to study how an early SSW shapes the whole season. The 2025 event suggested a long-lasting, relentless winter, one that would be remembered for its intensity and early arrival. The stage was set for a season unlike any in recent memory. When faced with an unusual event like the early 2025 SSW, forecasters look to history for guidance. Past winters with early SSWs like 2013-2014 brought brutal cold and heavy snow to North America. That year, polar vortex became a household term as Arctic air repeatedly plunged south. The atmospheric setup in 2025 closely mirrored those historic patterns. Data shows that early SSWs consistently lead to below-average temperatures and above-average snowfall across the US and southern Canada. The displaced Arctic air settles in, creating a stable, severe winter pattern. This historical context gave forecasters high confidence in predicting a classic, harsh winter for millions. While no two winters are identical, the echoes from the past were too strong to ignore. History provided the roadmap, and the atmosphere was following it. North America was the primary target for the Arctic air unleashed in early 2025. Forecasts showed a persistent pattern of below-average temperatures, likely to last through December and beyond. This wasn't just a cold snap, it was a prolonged chill set to impact daily life and energy use. As the frigid air moved south, it collided with moisture from the Pacific and Gulf of Mexico, fueling major winter storms. Regions that usually see rain or light snow now faced heavy, frequent snowfalls. The cold guaranteed that any snow would stick, raising the odds of a widespread white Christmas. While picturesque, this also meant hazardous travel and increased risks for holiday plans. Cities ramped up preparations, from salt supplies to snowplows. Residents were urged to winterize homes and vehicles for an early, intense season. The message was clear. This was no ordinary winter. The polar vortex disruption had set the stage for a memorable, challenging, big chill. While North America braced for Arctic cold, Europe's winter forecast was more complex, a tale of two halves. Early winter, from December to early January, was expected to be mild and stormy, with higher snow lines and rain at lower elevations. This was due to a westerly flow pulling in milder Atlantic air, keeping the coldest Arctic air at bay. Ski resorts in the Alps and Pyrenees faced a tough start, with heavy snow only at high altitudes. But from late January onward, the odds of a major pattern shift increased. Atmospheric blocking could draw cold air into Europe, bringing a colder, snowier second half. Scandinavia was set for more consistent cold, but Central and Western Europe would see a dramatic transition. The key was timing. Would the cold arrive soon enough to reshape the season? Europe's winter would be defined by this flip, from mild disappointment to a possible late-season freeze. The continent waited to see which story would unfold. Europe's two-part winter wasn't just about the polar vortex. Other climate drivers played big roles. La Niña, with its cooler Pacific waters, tends to bring stormier, milder weather to Europe. A warm Atlantic Ocean and the easterly quasi-biennial oscillation reinforced this mild, wet start. The North Atlantic Oscillation, or NAO, was the wild card. In its positive phase, the NAO brings strong westerlies and mild, wet weather. But a flip to negative NAO later in winter could block those westerlies, opening the door for Arctic cold. This potential mid-season shift was central to the forecast. A mild, stormy start, but a chance for a cold, snowy finish. The interplay of these drivers made Europe's winter forecast especially challenging. The timing of the NAO's shift would ultimately decide the season's character. For winter sports fans, the 2025 forecast demanded smart planning. In North America, the message was simple. Expect an early, epic season with deep snow and cold from December onward. Skiers could book with confidence, but needed to prepare for extreme cold and possible travel disruptions. In Europe, flexibility was key. Early season trips were best aimed at high-altitude resorts, as lower elevations risked rain and poor snow. The real prize for European skiers would likely come later, if the NAO flipped negative and cold, powdery conditions arrived. Monitoring the NAO became essential for timing the perfect trip. Understanding these atmospheric signals made the difference between a frustrating and an unforgettable winter adventure. In 2025, reading the weather was as important as reading the snow report. The right timing could turn a good trip into a legendary one. The polar vortex event of early 2025 was a powerful reminder of why understanding our atmosphere matters. The polar vortex isn't just media hype, it's a real force shaping our winters. Knowing how it works and how SSWs disrupt it helps forecasters give earlier, more accurate warnings. This knowledge lets individuals, cities, and energy providers prepare for severe weather. The 2025 winter also showed how interconnected our climate is. One event can bring deep cold to North America and a complex, shifting winter to Europe. Other drivers like La Niña and the NAO add to the challenge, making research and forecasting more important than ever. The polar vortex can define a season, bringing either mild weather or record-breaking cold and snow. As our climate changes, understanding these big atmospheric players is critical. The lesson from 2025: knowledge is power. By watching the signals from above, we can better prepare for whatever winter brings.